Okay, so we've got here a uniform rod. Okay, uniform rod means that the weight is evenly distributed, so the center of mass will be in the center of the rod. Because this is a 2-meter rod, okay, you can see then I put it right in the center there. So we've got 1 meter of the rod this side and 1 meter of the rod this side. In terms of my lengths, well, because I've got a reaction here at C, right? This is a support at C, so I've got because this is support, there's like a force pushing upwards to keep this balanced. Okay, I've split up my 1 here. Okay, this 1 meter on this side, because it said that AC is X. So if AC is X, well, of course, then that to the center then is going to be 1 minus X. Okay, so whatever's left from 1. So that's how you work that out there. And we need to obviously take note, it is in equilibrium. So when it's in equilibrium, we could say that forces up equals forces down. Okay, so they all balance. So force up in this case is the reaction at C, and all the forces down then are all these weights. So the weights of these two masses at the end, and of course the weight of the rod. So it'll be 5G plus 3G plus 2G. And if you work that out, we got 10G in total. Of course, 10 times 9.8, which is the value of G, you get 98 newtons. Okay. Then what we do then is we want to work out X, right? So we worked out the magnitude of reaction at C. Great. We need to now work out what X is. And we can do that by taking moments. Okay. So you can take moments about A, about C, or B. It's your choice. First, I'll take moments about A. Now, if I take moments about A, right? We need to appreciate that in a sense there's a hinge there at A, right? There's a hinge there at A, and we look at then the total moments clockwise. Total moments clockwise. That will then equal the total moments anti-clockwise. Okay, that's the principle of moments. Okay, when we've got a balance, when it's in equilibrium. Now, if you think about it, if that is my hinge there at A, right, then it's a bit like a clock, isn't it? Say that was the center of your clock. Well, if you're going in this direction, these arrows are going clockwise, aren't they? These ones here. Whereas the reaction arrow is actually going anti-clockwise around the clock. Okay, so the clockwise moments will be this force acting at A and this force acting about A. And then, of course, the anti-clockwise will be the R acting about A. So let's do the moments then of this force here, 3G. So force times the perpendicular distance, and the distance there from 3G to A, well, remember that's the center of the rod, so to A it'll be 1. Plus then 2G, and to the center of the rod that would be 2. And that will equal then the reaction, the anti-clockwise moment, that would be times and the distance there, which is X. So if I work that out, that's 3G, that's going to be 4G, so that's 7G equals R times X. But of course we know R is already 98, okay, so and G of course is 9.8. So then to get X, then you just do 7 times 9.8, we'll work that out in a minute, and of course take that 98 over and divide. We get X to be 0.7 meters.